Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.30. While solving this problem, we will be using Kirchoff's voltage law. This law states that sum of supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. According to this law, cumulative supplied and dropped voltage in a closed loop is always 0. Now move towards the problem. Exercise problem number 2.30. Find voltage V1, V2 and V3 in given below figure. This is the circuit diagram of given problem. We have to find voltage V1, V2 and V3 inside this circuit. If we observe, the only information that is provided inside this circuit is in the form of voltage, and it is asked to calculate voltage as well. No other circuit elements parameter is specified. So we will use Kirchoff's voltage law to solve this problem that is purely based on voltage. In this circuit we have multiple closed loop paths, but we will adopt these four paths. We will start from here. First we have to identify the direction of current. I am taking the direction of current clockwise. You may take counterclockwise as well. Now write Kirchoff's voltage law equation for this closed loop circuit. We will start from here. Current entering terminal is positive, so voltage across this resistive element will be taken with positive sign plus 6 volt. Move to next resistive element. Current entering terminal is negative, so voltage of this resistive element that is labeled as V1 will be taken with minus sign, minus V1. Move to the voltage source. Current entering terminal is positive, so voltage of this voltage source that is 4 volt will be taken with positive sign, plus 4 volt is equal to 0. Now inside this equation we only have one variable, that is V1, and we are interested to calculate its value. So solve this equation to calculate the value of V1. Add 6 and 4 together, it will become 10 volt minus V1 equal to 0. Now place this minus V1 on the other hand side of equal to make it positive. So the value of V1 will become 10 volt. Now in next loop we have two unknown voltage values. So for right now we cannot solve it. We will move to this closed loop. First we have to identify the direction of current, that is obviously selected clockwise direction. Now we will write Kirchoff's voltage law for this closed loop. We will start from here, minus Vx, move to next element. Voltage across this voltage source will be taken with positive sign because current entering terminal is positive, plus 6 volt. Move to next voltage source. Current entering terminal is negative, so voltage of this voltage source that is 4 volt will be taken with minus sign, minus 4 volt is equal to 0. Now solve this equation to calculate value of Vx. That will become 6 volt minus 4 volt will become plus 2 volt. Now place this minus Vx on the other hand side of equal to make it positive and calculate its value, that will become 2 volt. Now inside this circuit we have a dependent voltage source whose voltage is depending upon the value of Vx. So we can calculate voltage across this dependent voltage source, that will become the product of 2 and value of Vx. So the value of Vx is 2. So voltage across this dependent voltage source will be 2 multiplied by 2, that will become 4 volt. Now inside this closed loop circuit we have only one element that have no voltage across it. So we can find out voltage across it using KVL. First we will assume the direction of current clockwise. Now we will write KVL equation for this closed loop. We will start from here. Current entering terminal is positive, so voltage of this dependent voltage source will be taken with positive sign, plus 4 volt. Move to next element. Current entering terminal is positive, so voltage of this resistive element that is labeled as V2 will be taken with positive sign, plus V2. Move to next voltage source. Current entering terminal is negative, so voltage of this voltage source will be taken with minus sign, minus 6 volt is equal to 0. Now solve this equation to calculate the value of voltage V2. Subtract 4 volt from minus 6 volt, it will become minus 2 volt, and place this minus 2 volt on the other hand side of equal to calculate value of V2, that will become 2 volt. We have calculated the value of V1 and V2 as well. Now we will try to find out the value of V3 using this closed loop. So apply Kirchoff's voltage law inside this closed loop. First we have to identify the direction of current. I am taking clockwise direction. Now write Kirchoff's voltage law equation for this closed loop. We will start from here. Current entering terminal is positive plus V3. Move to next element. Current entering terminal is negative minus 6 volt. Move to last element. Voltage across this resistive element, that is labeled as V2, and the value of V2 is 2 volt. It will be taken with minus sign because current entering terminal is negative. Now solve this equation to calculate the value of V3. Add minus 6 volt and minus 2 volt together, it will become minus 8 volt, and place this minus 8 volt on the other hand side of equal to calculate value of V3, that will become 8 volt. So the values of voltage V1 is 10 volt, V2 is 2 volt, and V3 is 8 volt inside this circuit. This was exercise problem number 2.30. Thank you. See you again in next video.